for this question, we're told that two particles, A and B, of masses 0.4 kilograms and 0.8 kilograms respectively, are connected by a light inextensible string. It says particle A lies on a rough horizontal table, so we can assume here that there will be some friction acting on particle A, which is 4.5 metres away from a small smooth pulley, which is fixed at the edge of the table, which is this part of the diagram here. It says the string passes over the pulley and B hangs freely, with the string taut 0.5 metres above horizontal ground. We're told that the frictional force of magnitude 0.08 g opposes the motion of particle A, and the system is released from rest. So we're going to start by completing this force diagram. So I've drawn particle A on that rough horizontal table, the light and extensible string going over the small smooth pulley at the edge of the table, and B hanging freely. So let's first of all consider the weights of each particles. So particle A is 0.4 kilograms, so weight is 0.4 g, going vertically downwards. And B, we've got 0.8 g. Now, B has a greater weight than A, so we can assume that the acceleration, that the particles will be going downwards, so A will be moving to the right with acceleration A. We're not told what the acceleration is, and B will be accelerating downwards because B is heavier than A. Now we're told that there is a frictional force of magnitude 0.08 g, which opposes the direction of motion of A. So we've got 0.08 g going this way. We've got the normal contact force that A makes with that rough horizontal surface, so we're going to call that R. We've got the tension that particle A experiences of the string, and then the equal and opposite tension from the pulley. Again, B, we've got tension in the opposite direction that the particle B is going. And we've also got it for the pulley. And that is it. Yeah, that's all of our forces. So part A, we need to find the acceleration of the system. So we're going to resolve for A and B to produce some simultaneous equations, and then solve those simultaneous equations to find value of A. So for A only then, we're going to consider each particle separately. So we've got three parts of the system here, which I've separated with these dotted lines. And we're going to just consider A here. So for A only, if we resolve in the direction of motion, we get T subtract 0.08 g is equal to 0.4 A. Here I've done the resultant force F is equal to mass times acceleration. So then for B, if we resolve downwards, we get 0.8 g subtract T is equal to 0.8 A. F, resultant force, equals ma. I'm going to call this one equation 1, this one equation 2. We're going to do 1 plus 2 to cancel our tension variable. So if we do 1 plus 2, we get 0.8 g subtract T plus T subtract 0.08 g is equal to 0.8a plus 0.4a. 0.8g T's cancel, so we're subtracting 0.08g from 0.8g, and we get 0.72g. That's equal to 1.2a. If we divide both sides by 1.2, we get that 0.6g is equal to a. So the acceleration of the system is 0.6 g meters per second squared. For part B, we're asked to calculate the time taken for B to reach the ground. Now we are told that B is 0.5 meters above horizontal ground before it's released. So the distance that it needs to travel to get to the ground is 0.5 meters. So we know that S is going to be 0.5. U, our initial velocity, well, it says that the system is released from rest, so U equals 0. T is what we are trying to find, so we're trying to find T, and we've just found out that A is equal to 0.6 g. Now 0.6 g is 0.6 times by 9.8, which is 5.88. So we need to use a solve that equation with S, U, T and A. We're going to use S equals UT plus a half AT squared. So 0.5 equals U times T, that's 0, plus a half times 5.88 times T squared. So 0.5 is equal to a half times 5.88, that is 2.94 T squared. So T squared is equal to 25/147. So T is equal to the square root of that. We're going to take the positive root because time has to be positive. And we get 0.412 to 3 significant figures. Again, we've been asked to find the time. We found a value of T, so we now need to write a statement to say what the time is. So the time taken for B to hit the ground is 0.412 seconds to 3 significant figures. For the next question, we're asked to find the total distance travelled by A before it first comes to rest. So first of all, we need to think of the system. Now, when B hits the ground, the string will go slack, so there won't be any tension in the string, and then A will start to decelerate. So B and A will travel, B will hit the ground, the string will go slack, and then A will start to decelerate. So we need to find the initial speed when this string goes slack, and we need to find the distance travelled by A between that initial speed where it goes slack and to when it goes to rest. We know that it travels 0.5 until it gets to that point because B travels 0.5 until the string goes slack. So A will have 0.5 metres, and then the distance when the string goes slack, that's going to be our total distance of A before it comes to rest. So the first thing we need to find is the speed of B when it hits the ground. The speed of B when it hits the ground will be the speed of A as the string goes slack. So that will be the initial speed as the string goes slack for A. Remember, we've got an inextensible string here, so we can assume the speeds of A and B are the same. So For the speed of B when it hits the ground, we've got U equals 0, A equals 5.88. We've just found out that T equals 0.412 and V is equal to V. V is what we want to find out, the speed as it hits the ground. So V equals U plus AT. So the speed of B when it hits the ground, I'm just going to write that as VB, just so when I'm finding speeds out later for A, I'm not getting confused. That is equal to 0 plus 5.88 times 0.412, which is equal to 2.42 meters per second. So the speed of A on the table is 2.42 meters per second as the string goes slack. So what we need to find then, so we know that when the string goes slack, for A, we've now got an initial speed of 2.42. We want to find out the distance travelled until it's at rest. So V is going to be 0. S we want to find out. And all we need to do now is find out what A is. And we can work out our distance travelled. So to find out what A is, if we look at part A, we wrote down these two equations. Now equation 1, we had T minus 0.08G is equal to 0.4A. Now we just discussed that when the string goes slack, the tension is equal to 0. So if we look at equation 1, we know that T minus 0.08G is equal to 0.4A. And tension is equal to 0 when the string is slack. So we've got 0.08G is equal to 0.4A. And so A is equal to negative 0.2G. So I can write that here now. We've got negative 0.2G. So I'm going to use V squared equals U squared plus 2AS for these values here. V is 0, U squared is 2.42 squared. We're going to add 2 lots of negative 0.2G times S. So that's equal to 2.42 squared, subtract 0.4GS. When we rearrange this, we can get that S is equal to 1.5 meters. So two significant figures. So when the string is slack, A slides 1.5 meters further along the table before it comes to rest. So the total distance travelled by A is the 0.5 meters that it travels before B hits the ground and the 1.5 meters it travels when the string goes slack, which is 2.0 meters.